Welcome to Ocula from the Foundry. Ocula is a unique set of plugins for Nuke that solve common problems with stereoscopic images and helps boost productivity in live-action stereo 3D compositing. My name is John, I'm one of the developers on Ocula, and this is a quick look at some of the functionality that Ocula gives you. Ocula can correct stereoscopic images so that they match, delivering an easier, more rewarding viewing experience. Ocula handles misaligned views. It can correct color differences. It can rebuild views to match the focus. Ocula also provides a set of tools to assist stereoscopic compositing seamlessly inside Nuke. You can retime footage. You can generate disparity to push effects between the left and right views. You can review that disparity to look for parallax violations or to check for changes in convergence. You can use it to rebuild views to fix plates, or you can change the interaxial separation to change the depth. And finally, you can build Z-passes if you have a match move camera without having to create 3D elements or digital doubles. Let's look at vertical alignment first. Stereoscopic images need to match horizontally to avoid eye strain. Even with well-configured cameras, the images can be misaligned. If I flick left and right here, you can see there's a vertical offset that needs to be corrected. And if those cameras converge, there's also keystoning that needs to be removed from the images as well. The Ocula Vertical Aligner tool can correct this by measuring the vertical mismatch across the plates. If I look at an anaglyph view of the footage, you can see that vertical mismatch. I can do a global correction with Ocula. Here are the corrected plates, and that global correction can be exported as a corner pin. I can also do a local per pixel rebuild to take out the vertical misalignment, and that allows us to handle differences in alignment with depth. There's also a colour shift in this footage that needs to be corrected as well. If I switch between the left and the right eye, you can see that the colour changes. We're going to view that as a checkerboard key mix between the two views, and you'll notice that the colour on the checks is different between left and the right eye. Those colour differences can add to the strain in the 3D viewing experience, and the Ocula Colour Matcher tool allows you to correct subtle variations across the image, as well as reproduce dominant changes at highlights and reflections. So let's switch to looking at the corrected plates, and you'll notice immediately that the checkerboarding has gone. We're also going to bring up our stereo review tool here, and we're going to examine that correction at different parts of the image. So here we're just reconverging at the converge point here, and we're still looking at the checkerboard key mix between the two views. And you'll notice that the checkerboarding in the views has disappeared. The colour of the plates have been matched perfectly. The Ocula Focus Correction tool matches views as well, here to correct variations in focus between the views. It works by deblurring and using the appearance of one view to rebuild the other. So here's a nice example of two views. Here's the left view and the right view, and you can see the right is heavily out of focus, and we're going to use the appearance of that left view to rebuild the focus of the right. And here's the rebuilt right view, and we can compare that to the original left. The focus now matches between the two views. Ocula has a retime tool to generate slow motion or fast action effects that works to recreate matched views. If I look at the results of the Ocula vector generator that's calculating motion, and I toggle between left eye and the right eye here, Ocula is calculating these motion vectors simultaneously. This is because retiming views separately can break the alignment, destroying the stereo 3D view. Ocula calculates aligned motion vectors simultaneously so that you preserve the stereo alignment in the retime. So let's have a look at the input footage that we had for this shot and play that back. And I've used the retimer here to do a 2.3 speed up on the footage. So it's going to calculate the motions for the left eye and right eye simultaneously and use those motion vectors to create in-between frames to generate a 2.3 speed up. So let's switch to the retimed footage. And this is the retime. So the thing to look out for here is any breaking in the image when it's rebuilt those frames. All Ocula operations are built on Disparity. Disparity is the vector that connects pixels between the left and the right views. Ocula delivers clean, accurate disparity fields, and this is crucial to getting great results in stereo 3D compositing. So this is an interesting shot to take a look at. let's have a look at the disparity that Ocula is calculating. If I tone that down a little bit and switch to look at the horizontal component, you can see that Ocula is calculating a nice, clean, smooth disparity field, but paying particular attention to the edges of the characters here. And that's going to be crucial for fixing this shot. So if I look at the original footage and flick between the left eye and the right eye here, you can see there's some large changes in the reflections. There's also some subtle changes in the reflections on the suit and the colour of the backdrop that we need to correct. And we're going to use the Ocula disparity and local colour matching to fix the colour of the left view by pulling across the colour of the right view using disparity vectors. So that's the original left. Let's look at the rebuilt left view and compare that to the original right. If we flick between these two, you can see that that colour has been corrected nicely. But the crucial thing here is to make sure that that correction holds up over time without introducing any flickering by copying that colour or any haloing effects. And we're only going to get that if we have nice, clean, stable disparity fields that pull the colour across. So let's play back the rebuilt left view and see if there's any flickering. And if we zoom in on the feet of the characters here and look at these edges, we can see that the result is nice and stable. Ocula has a disparity review tool that allows you to examine the parallax you have in your stereoscopic images based on those disparity vectors. So for this shot, if I look at a disparity histogram, it tells me the parallax I have in the scene. You can use this to check for any changes in convergence in your node tree. I've got a reconverge node here. If I look at the disparity histogram again, you can see there's a big shift to a negative parallax. There's a lot more content coming out of the screen now. And you can see here that it's violating my parallax limits. So I can switch to look at the parallax violation in the image. And now you can see which part of the images are violating those limits. And you can switch the limits to see where the violation happens. You can use disparity to rebuild one view from the other with Ocula. So here we're going to use the Ocula New View tool to take the left view and push it across to the right. So you can use that to push across paint fixes or even to rebuild broken frames. You can also use Ocula to change the interaxial separation for your stereoscopic images. So here's a rebuilt interaxial separation, and if we compare the parallax for our input footage with the result of the interaxial separation, you can see that we've changed the depth in the scene. Finally, you can build Z-passes by converting those disparity vectors to depth values if you've got a match move camera for your shot. So here we've calculated disparity and we're going to convert that to depth using those cameras. So here's the depth values. If I switch that up a bit, you can see we've now got depth per pixel for our shot to do 3D compositing in our stereo views. Now Ocula allows you to calculate disparity for different layers in the scene. So I've got a rotor here for each of the actors and a mask for the background, and we're going to calculate depth for each of those elements and pull them all together into a 3D scene. So here's our final scene created with the match move cameras, and I can rotate around and we can use this to place elements in 3D and composite them back into the shot. So that's just a quick look at some of the tools you get in Ocula. Ocula fits seamlessly into Nuke, and it gives you the flexibility to handle a lot of the problems in stereo 3D VFX work directly in your Nuke compositing pipeline.